It's log. It's log. It's big. It's heavy. It's wood. It's log. It's log. It's better than bad. It's good. That's right. Today we're talking about calculations involving pH. Hit the theme.
Ain't nothing but a chem thing, baby. Two flipped out teachers going crazy. Lancaster is a district that pays me. Unbreakable, so please don't try to break this. But back to the lecture at hand.
Hello and welcome to another episode of SchuFu coming at ya. I'm your host Fu, and with me as always is Shu.
Well, hello there, dweebs.
So Shu, in the last video we introduced the pH and POH scales.
Yeah, and in today's video we're going to learn how to calculate pH and POH using logarithms. So let's get started. Calculations involving pH, a lesson from the acids and bases unit. Intro. Remember that the pH scale relates to the exponent of the molarity of hydrogen ion. More specifically, it is a logarithmic scale. When you take the log base 10 of x, you are determining the power of 10 that gives you x. So for example, if we take the log base 10 of 100, that equals 2, because 10 raised to the second power gives me 100.
Calculating pH. The formula is pH equals the negative log of the concentration of H+ ions in molarity. Substitute in the molarity of the hydrogen or hydronium ion. The final value is unitless. Since the answer represents an exponent or number place, the value has no true sig figs. Instead, the sig figs are expressed as the number of decimal places of the pH. All right, ladies and gentlemen, we have an example problem here for you. Shu, are you ready?
I am.
All right, what is the pH of a solution that has a hydronium ion concentration of 4.6 times 10 to the negative 11th molar? All right, this is a calculation, and like all calculations, we're going to do it FSA. So Shu, what is my formula?
The formula would be pH equals the negative log of the H+ concentration.
All right, what is the question asking for? Let's circle it in the question and in the formula.
All right, it says what is the pH? So I'm looking for pH.
Good, so now we're gonna substitute, and there's only one variable left in our formula to substitute. So what are we gonna use?
All right, well it says the hydronium ion concentration is 4.6 times 10 to the negative 11th molar. And hydronium and hydrogen are the same thing.
Yeah, H3O+ is the same thing as H+. We use them interchangeably.
So I can just sub that directly in. I'm taking the negative log of 4.6 times 10 to the negative 11 molar.
Okay, last thing to do is to plug this into our calculator and get an answer.
All right, so when I plug this in and take the negative log of that number, unround it, I get 10.3372. That's unrounded. Well, I'm not sure about the unit. Is this molar for my final unit?
No, actually, pH is a unitless number, so we have no units here.
Oh, okay, so we're good with that.
Yeah, so why don't we figure out the sig figs here? Why don't you walk us through that?
Okay, so if I look at my original measurement, that would be 2 sig figs. And normally I'd want to just make this 10 point, right? That would be 2 sig figs normally, but with pH, you were talking about how it's the placeholder, that number place is represented by something like the 10, so like to the 10th power or negative 10th power. So I get my sig figs from just the decimal places. So 2 sig figs would just be from those 2 digits, not from the 10.
Okay.
So I circle 7 and I round up to 10.34. It looks like 4 sig figs, but again, 2 decimal places means I only have 2 sig figs because it's a pH.
Good.
Calculating POH. The formula for POH is POH equals the negative log of the OH- concentration. Substitute in the molarity of the hydroxide ion. Also, we can move between pH and POH using the following formula. pH plus POH equals 14. Okay, we're gonna do some more examples. Are you ready, Fu?
I'm ready.
All right, A. What is the POH of a solution that has a hydroxide ion concentration of 2.45 times 10 to the negative 3rd molar? Let's start out with our formula. What formula will we use here, Fu?
All right, we're gonna use the POH is equal to the negative log of the OH- concentration.
Very good. Let's circle the variable that we are solving for.
Looks like the question's saying, what is the POH? So POH.
Good. And we only have one number to substitute, so let's do that next.
All right, POH equals the negative log. And looks like they give me the OH minus concentration up here. So 2.45 times 10 to the negative 3 molar.
Good. All right, let's plug that in. We can leave our answer unrounded. We'll do sig figs at the very end.
All right, so my answer is 2.6108.
All right, good. We don't need any units because like pH, POH does not have any units. All right, for sig figs, let's look at our original measurement.
Looks like it's 3 sig figs with 2.45.
Good, 3 sig figs. When we translate that into pH or POH, we want to use just decimal places. So we want 3 sig figs as 3 decimal places.
Okay, so then 2.611.
Very nice. Let's move on to B. What is the pH of this solution? So we have the POH from A. We're going to find the pH in B.
Okay.
What formula do you think we can use here?
I think this lends itself nicely to the pH plus POH equals 14.
Good. All right, and we are finding what in this problem?
pH.
Good, pH, so let's circle that.
Okay.
Good. All right, so now we're gonna substitute. Let's actually use the unrounded POH just so we make sure we have an accurate answer at the very end.
Okay. So pH plus 2.6108.
Good.
And that'll equal 14.
All right. So we're going to be doing some subtraction here.
Okay. And what do we do for sig figs here?
For sig figs, we're going to just use the original number from A. So 3 sig figs. So again, 3 decimal places.
Oh, okay. So 11.389.
Looks good. You try number 1. Find the pH and POH of a solution in which H3O plus concentration equals 3.2 times 10 to the negative 5th molar. Use proper sig figs. Make sure you show your work FSA as well.
Calculating H plus concentration. The inverse of log is antilog, or 10 to the x. To find the molarity of hydrogen ion, simply type in second log of the negative pH in your scientific calculator. So the formula is the concentration of H plus ions equals 10 to the negative pH. For sig figs, you want to take the decimals of the given pH and translate that into the total sig figs for your molarity. All right, ladies and gentlemen, we have an example problem for you. Shu, are you ready?
I am.
What is the concentration of hydronium ion in a solution with a pH equal to 4.324? All right, like all calculations, again, FSA. So Shu, what formula are we going to use?
We're going to use the formula. The concentration of H plus is equal to 10 to the negative pH.
All right, good. What is this question asking for?
It says, what is the concentration of hydronium ion?
Good, and what is that in our formula?
Well, hydronium's the same as hydrogen, so the molarity of hydrogen.
Okay, good. Let's substitute this. We have one number to substitute.
All right, so H plus equals 10 to the negative pH. The pH is 4.324.
Okay, now all we have to do is plug this in our calculator.
All right, so I want to make sure I hit second log and then the negative pH. And what I get is, let me think about sig figs before I write down anything. So I'm going the other way now, right? So if I'm looking at a pH, I ignore the 4. The 3 decimal places means 3 sig figs. But since this is a molarity, I'm not going to look at decimal places. I'll look at total sig figs. So I want 3 total sig figs, 4.74, that's 3 total sig figs, times 10 to the negative 5th. And then does this have a unit?
Yeah, this is concentration, so what's our unit going to be here? When I have it in brackets, what are we using?
We're going to have molar as the unit.
Good.
Calculating the OH minus concentration. The concentration of OH minus equals 10 to the negative POH. Substitute in the POH, which you may need to find from the pH first, or alternately, the H plus concentration times the OH minus concentration equals 1 times 10 to the negative 14. Okay, we're going to do one last example. Are you ready, Fu?
I'm ready.
What is the hydrogen ion concentration of a solution that has a pOH of 1.234? All right, this one's a little bit complicated, and we're gonna do a few different calculations, but I'm gonna kind of walk you through. Now, if we're trying to find the hydrogen ion concentration, we're actually gonna need the pH first. So given that we have the pOH, how can we find the pH first? What are you thinking?
Well, we got a pretty straightforward formula of pH plus pOH equals 14, so that should be able to give me the pH pretty easy.
Good, let's start with that.
And if I substitute in pOH of 1.234, I get 12.766.
Good, we just have to subtract there. All right, now we're not done because they want the hydrogen ion concentration, right? So how can we find the hydrogen ion concentration from the pH that we just found?
All right, so we have the formula that the hydrogen ion concentration is equal to 10 to the negative pH, right?
Very good. All right, we can substitute in our pH now.
Okay, so that was right here. So the concentration of H plus is going to be equal to 10 to the negative 12.766.
All right, good. Now we're gonna get an answer. Our answer needs to be to, let's look at the sig figs in the original question.
All right, well, this is pOH, so I'm just gonna look at the decimal places for the sig figs.
Good, so we have 3 decimal places.
3 sig figs then that I need in my total for my answer.
Right, yeah,
Right?
so
Okay.
3 total sig figs because now we're going to be in what unit?
Molarity.
Molarity. Good.
Okay, so I get 1.71, there's my 3 sig figs, times 10 to the negative 13 molar.
Looks good. You try number 2. What is the hydroxide ion concentration of a solution that has a pH of 7.45? Use proper sig figs and make sure to show all your work.
All right, ladies and gentlemen, we did a lot of calculations in this lesson, but you don't have to memorize any of these formulas. They can all be found on Table T in the acidity and alkalinity section. Well, that's going to do it for today's episode on calculations involving pH.
See you around town, dweebs.
Today's episode is brought to you by Log from Blammo. It's log. It's log. It's big. It's heavy. It's wood. It's log. It's log. It's better than bad. It's good.
But we never off, always on till the break of dawn. SCIENCE in the hall they call S-Wing. You know we never wear a tie like my homies, boys to men. It's so hard to say goodbye.
Like this, that, and this, and it's like that, and like this, and like that, and it's like this.
You're going in low power mode.
Plug and chill to the next episode.